Hello Math 20-2 and welcome back. Today we are doing reasoning with angles and triangles, lesson 4. So we're looking at this and it says polygons. Well, you might start thinking, what does this have to do with this lesson? Well, basically you'll find out in this lesson that polygons, the interior angles, and the exterior angles, and the central angles are all based off of triangles. And we could end up tackling many problems using triangles and finding the angles of triangles in polygons and combining other shapes with polygons and triangles with polygons. So that's why we're doing this lesson here. It flows in nicely. It's a really, really interesting lesson. So here we go. First of all, what is a regular polygon? A regular polygon is a shape with more than two sides that each sides are the same and each interior angle is equal. So an equilateral triangle is one example, a square is another example, and a pentagon here, where every side is the same, is another example. Okay? So we continue this off. We're going to look at this table here, and we're going to try and figure out what it means. So they start off with a triangle. Well, a triangle has three sides, right? Well, the interior angle of a triangle is going to be 1/3 of those sides, because to find the interior angle, we go from the vertex, so this little point there, and we go all the way into the center. Vertex all the way into the center. So there's three lines coming in. So it's 1/3 of a full circle, which is 360. That gives me my interior angle of a triangle. So basically, I have to go 360 divided by 3 to give us that 20 degrees. Okay? So the next one we're going to look at is we're going to find the base angle of this interior triangle. So the base angle is this guy here. Well, looking at this, these are all isosceles triangles because this is all a radius going in. So these distances must be equal. Therefore, this angle must be equal as well. Now, these are the same, so if this is A, this is A, all I have to do is the sum of interior angles of a triangle is equal to 180. So I minus this angle from it, and then whatever that difference is, I'm going to divide by 2. So we go 180 minus 120, which is the central angle, and we divide it by 2 to get the two base angles. Now, looking at this even more, this can help us find our interior angle. Our interior angle is this whole thing. Well, that's made up of two base angles. And like we said before, in a regular polygon, these base angles are equal. Okay? So we go for the base angles, we have to for the interior angle, we multiply our two base angles, or our base angle by 2. And our base angle is 30 degrees, because there's two of them. Or we could add 30 and 30. So that's going to give us 60 degrees. Now, to find out the sum of interior angles, well, we just take a look at this. How many interior angles are there? 1, 2, 3, which is n actually, because it's a triangle. And so we multiply all interior angles by 3, so there's 60 by 3, and that gives us 180. And that is the sum of a triangle. We've known that from before. So now let's try this next one here, which is a pentagon. So we're going to look at a pentagon. Okay? So a pentagon is 5 sides. So I'm going to first start this off. We have 360 divided by, well, here's my pentagon way up here. Zoom out a bit so I don't have to shift back and forth. My pentagon's up here, and the full circle in the center line is 360. We have all of these radius going to the center. We just want that. And so there's 5 triangles that make up that. So I'm going to go 360 divided by 5. Okay? So we have 360 divided by 5. Now what is that equal to? 72 degrees. All right. Now, the next part says we want to know the measure of the base angle for the triangle. So the base angle. Well, like we said before, 2 of these here are the same because these are radiuses. So I go 180 degrees because this is a triangle, an isosceles triangle, minus my central angle, which is 72. And then I'm going to divide it by 2, because these two things here plus that angle must add up to 180. And these two are the same, so we could just go 180 minus the central angle, then divide by 2, which is going to give me, in this case, that's going to give me 108.54. Okay? Now, we know that these two angles are the same, right? And they're both base angles, so we multiply that by 2, and that will give me my 108 degrees. So my central angle is 108 degrees. Now a pentagon has 5 vertices, so 5 central angles. My interior angle is 108 degrees. And a pentagon has 5 vertices, so 5 interior angles. So what is the sum of interior angles? 5 multiplied by 108, which will give me a total of 540 degrees. Okay? Now, I'm going to give you guys a little bit of time here, so pause and finish the nonagon and decagon and see if you get the pattern going and you get familiar yourself with this process. Okay, so hopefully you paused. Welcome back. So now we're looking at the end-sided polygon. So, end-sided polygon, there are end sides. What do we first do to find the measure of the central angle? We go 360 and we divide that by n. Next, what do we do? Well, what does that equal to? Well, next we have to go, that is, well, 360 divided by n. There is no it's equal to, it's just what it equals. It's algebraic. So the next part is we want to find the base angles. How do I find the base angle? Well, I have to divide this here by 2. So I go 180, and we have to so here, sorry about that, so here we're going to go 180, and we're going to subtract 360 divided by n, and because there are 2 of them, they're the same, and then we divide by 2. We're just following the formula what we're doing there. Now the next part says the measure of the interior angle of the polygon. So now we have to find the interior. Well, there's 2 of them. So I multiply this here all by 2, right? So if I divided by 2 last time, now I multiply by 2, I'm going to end up getting 180 minus 360 divided by n. Okay? Now in the last step, it wants me to, I'm just going to zoom in here because it's getting very fine in detail so we can really see it. So the last part says, now we want the sum. So I have to go 180 minus 360 all over n. Now we're multiplying all of that by n. So what does that give me? Well, both of the n has to be multiplied into both of those. That's going to give me 180 n minus 360. Okay? So that's how we do that. Now we're going to come back to that later as we look more. So the next part here, we're looking at some polygons. Now these last example were regular polygons. Now we're looking at irregular polygons. So irregular polygons are polygons where the sides aren't the same. For instance, a rectangle, isosceles triangle, scalene triangle. Look at this pentagon here, a rhombus, something like that, or even okay, so the sides and angles aren't all the same. But basically, if we look at this, no matter what, we could divide them into triangles. Even if we take these big shapes here, we could divide these into triangles. So we just take one vertex, and we start fanning out from that vertex. Just like this. So we fan out. I am not a very good artist, but I try my best. And we're going to take and you'll find a relationship between the amount of triangles and vertices. So let's take this one here and fan out as well. It's just to make our triangles, to see what kind of triangles make the shape. And there's one more right there. So if I take a look at this, this is a 8-sided shape, I believe. 1, 2, 3, 4, 5, 6, 7. So we look at this, this is an 8-sided triangle. 1, 2, 3, 4, 5, 6, 7, 8. So it's an 8-sided polygon. How many triangles are there? 1, 2, 3, 4, 5, 6. Interesting. So n is equal to 8. Triangles are equal to 6. This is a 10-sided, we'll come to that later. So we go look at this table here. And we have a triangle. Triangle has 3 sides. Well, it's just one triangle. We look at a quadrilateral, 4 sides, 2. Let's take a look at the pentagon here. Pentagon. We have 5 sides in pentagon. How many triangles make up this pentagon? 1, 2, 3. Interesting. So 5 sides. We have 3 triangles. So we go 180. So we continue this and we get 180. So let's look at the octagon. Or sorry, we get 180 multiplied by 3 is equal to 540. So now let's take a look at an octagon. Octagon has 8 sides, and we have 6 triangles. Take a look at these relationships. So 6 triangles, so that is 180 multiplied by the amount of triangles, because the sum of each triangle is 180 degrees, so we multiply by the amount of triangles, which is 6, which will give me 1040 degrees. So that's very interesting. So now I'm going to give you a minute to try, a couple minutes, pause it, and try and figure out the next 2. Okay? So here we go. Now we're going to look at the end-sided polygon. So we have end sides. What do? To find the amount of triangles, hopefully you found the relationship, we just go the number of sides and we subtract 2. Okay? Then we multiply that by 180. And that's all we have to do. So, and that's how we made this formula here, and which is the sum of the interior angles. And then if we want to know what is each interior angle, the measure for each, we just divide that by n. And if we do that, we end up getting the second formula right there. These formulas will be most of the time given to you, but it's good to know how they were created. In part 2 of this lesson, we are going to go over some examples.